Hi, good day, and welcome to my YouTube channel. And today's video, we're going to make an example of component method under the topic vector addition. And, we remember that the component method is a single vector quantity that can be broken down to two or more scalar quantities using vector components. Now, to make it easier for you to understand, so what if we're going to put the vector r with the direction theta on our x and y axis of the Cartesian coordinate. Now, to evaluate this vector r, now remember that the description or the definition of the vector or the component method is that a single vector has two components. No? This one here, vector r, is found or can be found on the x as well as on the y. Therefore, it has or it possesses two vectors that can also be found on our y-axis and x-axis. So therefore, the component of r, of vector r, that can be seen on the y-axis is, we call that ry, or usually it is denoted with ry. So in this video, we're going to use, for uniformity purposes, we will use ry for the component y of our r. And for the component x of our r vector, it is denoted with rx. Okay, so we have already formed a right triangle here. Now, if we're going to analyze the values or the measurement of the sides of this right triangle formed in our x and y axis, we can review or we can understand that this follows the principle of the Pythagorean theorem. R here can be would be our hypotenuse. So if we're going to form the formula of the Pythagorean theorem, we can say that r squared as our hypotenuse is equivalent to the rx squared plus ry squared. And here theta is found. Now, if we're going to define the individual values the individual formula and value of rx and ry, rx is equivalent to simply r cosine theta as well as on ry is r sine of theta. It's because again of this relationship, the right triangle. And then theta here is equivalent to the arctan of ry all over rx. Now, let's get to the example. Okay, so this was the example that I have left you during the previous video. Okay, two forces F1 and F2 with magnitudes 20 pounds and 30 pounds respectively act on an object at a point P as shown. Now, find the resultant forces acting at P. Now, this problem, it is really stated here that resultant forces must be found. Meaning to say, we are going to find two forces which relates to or in accordance to the F or our resultant. Now, firstly, we're going to obtain F, and then the specific answer for this problem is its component lang. Okay. So in this figure, we can see that we have force 1 and force 2 found at point P. Again, your F here is your R. Okay. Now, let's use what we have learned on the previous slide. Okay, so again, in the component method, we have the relationship that are resultant. Let's say equalness sa F natin is equivalent to the summation of let's say this is square ha. Okay, because of the Pythagorean theorem. The summation of forces along x square plus the summation of forces but then again, R is not the final answer here. We have to find its component. Actually, the component of R here is just the F of summation of x along x and the summation of force along y. That's it. That's what those are what we are going to find here. And remember that the direction of this r here is equivalent to theta. Okay. Then arctan of summation of 4 just to find the theta. Now, remember, during the previous slide, okay, we have Rx, relationship of Rx, R is equivalent to cosine, R cosine of theta, and then for R1 is R sine of theta. We will be using this later on just to check the values if it is accurate or if it is right. Now, it's going to find it. Now, once you are going to form the summation of forces that can be found on the horizontal and on the vertical respectively, we must follow this principle, the action and reaction by Newton's law. Okay? So, and then also we are going to consider the sign convention of those forces. Summation of forces along x or along horizontal is equal to 0. And then for the sign convention, since we're dealing with the horizontal or the x, going right of the quadrant is positive, no? Going to the right of our quadrant is positive, and then going to the left of our horizontal is negative. Okay, again, that can be used for our sign convention. Now, what are the present forces here on our horizontal? Okay, see that F1 is going rightwards, that's why it is positive. So F1, okay, this is F1, and then the as you can see here, is 45. Therefore, by right triangle principle, this is cosine of 45, and then that is positive. Now, on the other force F2, this is, since going leftwards is negative, this is negative. So F2, and then again, let's evaluate this. Okay, this is what's the theta here? This is 30 degrees, and then this is a right triangle na principle ating susundin. So we have negative F2 cosine of, okay. So what's the value of this? F1 cosine 45 minus F2 cosine 30. We have to plug in the values of F1 and F2 so as to get the summation of forces. So F of 1 is cosine. So the answer here is negative 11.84. Okay, negative 11.84. Okay, please do not forget your unit. This is pounds. So now this is our component that is found on the horizontal. Okay, so it directs a negative sign because it's going once. Now next, we're going to find the summation of forces along y is equal to 0. Now we are to consider the Cartesian in the Cartesian plane. We're going to consider y-axis. So going upward, we set that as positive for our sign convention, and then going downward as negative. So forming the equation, summation of forces along y is, so all both F1 and F2 are positive because it's going upward. So F1, that is sine of 5. So let's just use the same principle, and then plus F1 sine 45, and this F2 sine of 30. The principle is being the right triangle principle is being followed. So plug in the values of F1 and F2 to solve. Answer here is 29.40. Okay, this is actually the values key components of our result time. 11, negative 11.54 pounds and 29.4 pounds. Now, if we're going to check if this is correct, so let's try to solve the data first. If our values are accurate. So arctan, our direction of the resultant is arctan of summation of force along y is 29.14 divided by negative 11.54 of along x forces. So the theta here is equivalent to negative 67. 89. Now the theta that is negative 67.89 degrees, that's equivalent to 112. This is equivalent to 112.11. So how did I do that? So that's basically 189.67 lang po. This is just for checking lang. And R here, by using this is 1 is 4 is principal of the theorem. R here can be obtained. Pythagorean, this is equal to 51.45 pounds. This is the magnitude of our F or R. Okay. Now, if we're going to test the accuracy of our answer here, so let's use this relationship. So Rx, we have Rx is equivalent to R cosine theta. So plug in values of R, we have 31.45 cosine of 112.11. So the answer is negative 11. So this is the same with what we have obtained a while ago. So meaning to say our answer is correct. And then Ry is equivalent to the R, which is 31.45, and then sine of 112.11. The answer is 29. Same. Meaning to say, what we have obtained a while ago are on after. So now I hope that you have understand the concept of component method, and thank you for listening. Appreciate what I have ready prepared for you, and thank you and God bless. Bye.